It's the first time I've seen it, and I'm going to do my best to do it justice for her. Okay, so please bear with me. So the presentation will cover just a little bit of background into residues, and then go into how we're going to remove it, and how we're going to validate that we've removed it, because it's not really easy. And we'll look at some different methods that we've tried and see what effect we have. So in the clean rooms, we look at two types of residues. So one are process related, so raw materials, greases from machines, things like that, buffers. And then the other is the chemical residues that you get from using detergents and disinfectants. They're a problem because they can be a slip hazard, particularly detergents and quaternary ammoniums. They can interfere with proper disinfection by having an adverse effect on the disinfectant you're using. When you have visually unclean windows, for example, with smears, it can prompt more questions from the regulators to see what's going on and whether everything's in control. And if you don't remove them, certainly a build-up of chemicals can cause corrosion of your equipment, which is expensive. So, GMP Annex 1 now makes reference to removing residues. Before, they used to just reference cleaning, and now they have two very distinct steps, one which is cleaning and one which is disinfection, because you're trying to achieve two different things. And there is a very specific phrase in there that cleaning programs should effectively remove disinfectant residues, and that process should be validated. So as usual with anything regulatory, they never tell you how to do it. They just say that you should do it. So this would be part of your CCS that you would have to include to make sure that you've covered this point. So almost all disinfectants will leave a residue. The exceptions are alcohol, 70% IPA or ethanol, and hydrogen peroxide. Everything else will leave a residue of some description, and some are worse than others. All detergents with surfactants in them will leave a residue. And there's no really approved standard of assessing how much residue is too much and the removal of it, really. So I suppose as part of your CCS, you need to have something in there to demonstrate what you've done and why you've done it. So residue on evaporation can be a useful tool. So you can see how much residue you are going to get from your disinfectant. And it varies on the concentration of the product, the number of stabilizers you've got in it, and other additives that might be in there. And just because it's a low concentration of active ingredient doesn't mean it's a lower residue if it's got lots of other additives in it to stabilize it. So here are some examples of residue on evaporation. You can see that IPA and hydrogen peroxide are very low. And then as you go through, things like quaternary ammonium and hypochlorites, they get higher. Yeah, you get lots of different types of residues. So they might be powdery. They could be colored depending on the type. I'm thinking of one in particular that's a pink powder that you put in solution, and then when the water evaporates, you're left with lots of pink powder. So sticky residues come from quats usually. So yeah, there's all sorts of different types basically. And depending on the surface, it can look very different. So if it's on glass or some highly polished surface, it will be very visible, but you won't necessarily see it on your floors. So you can have residues and not be aware of them, for example. So this is just showing on stainless steel, powder-coated steel, and so on, that the same amount of residue applied to each of those surfaces looks very different. So as I say, highly reflective surfaces like glass mean that it's easier to have a look. If you have got residues on your windows, it probably means that you've got residues on your floors and so on as well. The best thing to do with disinfectant residues is stop them building up in the first place. So once you've allowed the contact time, if the surface is still wet, wiping or mopping to dry is the best way to make sure you don't get a build-up. If you do get a build-up, it's best to solubilize it first and then remove it with a dry wipe. You can use water for injection if it's a high-grade clean room or appropriate quality water. Alcohol may be more appropriate for certain types of residues. And of course, if you've got proper dirt, you will need a detergent. I'll move on from that. The residues do change over time, and they don't end up with a residue that's a uniform layer. They can sort of like have, more concentrated residues in some areas than others, depending on the surface. And it also depends how long you leave it. So we did some work on a disinfectant that if you left it for a week and then removed it, or 2 weeks and removed it, 3 weeks, it was fine. By the time you got to 4 weeks, it had become much, much more difficult to remove that buildup of residue. So if you can't wipe to dry because the contact time doesn't let you and the product has dried, we would at least say, you don't remove it, I don't know, check with the manufacturer on residue removal and put something in place, whether it's once a week or once a month, to make sure that you keep it to a minimum. Sorry, I say I'm not familiar with this presentation. No. So the ways to avoid it, apart from removing it immediately, is using low residues. I say it's quite difficult to find them, and set a regime to do it routinely. So I said it's very difficult to quantify residues. The only standard is really a visually clean standard. So we wanted to do just a little bit of work to see if there was some way we could try to quantify what's happening. So there is a standard, the standard practice for qualification of visual inspection of pharmaceutical manufacturing equipment and medical devices for residues. So there is a standard which you can follow. That's up there. But again, it's a visual thing, so it's very subjective. What somebody sees as being visually clean, somebody else might feel it's not. So we thought we would do a little bit of work, as I say, so trying to put a scale in for visual assessment, looking to see if haze mirrors on mirrors might help, and a fluorescent tracer and pixel analysis. So that's where we add a set amount of fluorescent tracer into the disinfectant and apply it to a surface, and then we can see what's going on. So this was the visual one. As I say, I think we can all see on the left that it's quite a significant residue, but even once you've wiped that off, I say some people might think that it's okay and others might not. We tried a haze meter, but it was very, very time consuming, and the results were inconsistent with what we'd seen visually. So they didn't align, so we decided this was not a good method to be using. This is from the fluorescent tracer. So we start with the clean surface. We used a wipe to apply the disinfectant residue, and then we dry wiped it to remove the residue. So you can see super clean, not clean, much better, but still not perfect. And this correlated much better with the visual checks that we'd done, so that this tied in much better with what we could see. Initially, they used a very small bit of steel, but it didn't give them enough points to look at, so they then used a larger piece to get a better view of what was going on. We used this to look at the buildup of residue over time. So this is a product that contains alcohol and quaternary ammonium. We applied it by wiping onto the surface and let it dry, and then we added another layer and another layer, up to six applications we did. And this is what we saw. That one. So, is that the right one? Can't find my pointer. So you can see it started very low, and then on the second time that we applied it, it was much higher, and so on and so on. And you can also see that it wasn't linear. It was, variable each time. So then we looked at how we could remove the residues, again using the fluorescent tracer. and the 18 sampling locations. We did 5 replicates for each trial we were doing, and allowed them to dry, and then compared the results. So we had a 1 layer of dry residue, and we tried to remove it with a dry wipe. Then we had 1 layer of dry residue, which we tried to remove with a commercial pre-saturated wipe with 70% IPA. Then we had a dry residue that we sprayed with IPA, and then used a dry wipe to wipe it all off. We had a dry residue where we got a wipe, we sprayed onto the wipe, and then used that to remove it. And finally, we did 6 layers of dry residue on top of each other, and used the pre-saturated wipe again to see what would happen. So this product is a accelerated hydrogen peroxide disinfectant. So although the active ingredient is, the active substance is a low residue product, it does have stabilizers and surfactants and things in it, which then increases the level. So as you can see on here, it was the same thing again, wiping it with the IPA wipe in this instance. So we cleaned the surface, we applied the residue, we wiped it, and then we calculated the efficiency. Now, you need to bear with me on this slide because whoever created the graphs used different scales, so it's not quite as obvious as it could be. Can I use this? Still doesn't use it. So, before application, if you look here, you can see it's got about 16 units that they had there. And then after we'd applied it, you can see it went up to 60, 80, 100. After we wiped it, it came right back down again, back to pretty much the yellow one here where it was before. And then if you look at the removal as a percentage, again, it varies from 100% down to sort of 40%. And that's a function of the operator doing different things while they're wiping. As I said, the residue is not a linear thing when you apply it, so it's just variable, basically. So these were the 5, this is an example of what they did. These are the 5 samples where there was 1 layer of disinfectant and then a pre-sat wiper to remove it. When we look at all the different methods together, you can see, predictably, that a dry wiper on a dry residue is really not effective. The pre-sat wiper on the dry residue is better. The one that we sprayed directly onto the surface with the spray and then dried it gave the best result, followed by the one where we sprayed onto a wipe and then removed it. And then the one on the end here is the 6 layers using a pre-saturated wipe. So using the fluorescence and tracer dye, you know, we managed to get some sort of a slightly more quantitative view of what was going on. But literally, I mean, this is just a start, and we're going to do a lot more work to see if we can improve it and get to a truly quantifiable method and process and so on. But the one thing that we took as a take-home from this is that if you've got a dry residue, solubilizing it in whatever way and then removing it with a dry wipe is by far the most effective way to remove your residues. So, and the main thing is that as well, don't let it accumulate in the first place. Try and wipe to dry after the contact time if you can. Thank you very much. That's it for now. Any questions?
Has anybody got any questions? Thank you for stepping in for Carol. Yeah.
Yes, the results you showed that what seems to be most effective is spraying directly the liquid in the surface and then what dry, correct? We did help a client develop an SOP which we tested all the options.
Yeah.
And in the visual there was no way because it was a filling machine, and it certainly was the same result.
Oh, that's good.
However, it's very challenging for the way people are used to do things in pharma and particle counters. So I expect a lot of discussion on this because honestly, nobody has a real clear view of how to go with the residues. Apart from this result,
Yeah.
So from the engineering point of view, keeping your surfaces maintained properly is probably a sound decision if you want to avoid contamination. So is it that you end up cleaning before applying a sponge and cleaning afterwards?
I would suggest cleaning after, or not cleaning, removing it afterwards, as you say, so that you don't leave a sporicide in contact with the surface longer than required. And subject to what you're doing next, that surface should still be clean before you use the sporicide again. I mean, if you had time, you would do both, but most people won't. So I would say do it immediately afterwards.
Okay, any other questions for anyone?
Thank you.
Thank you very much.